Hello, welcome to my third tutorial video on using the EppicDEM software. In this tutorial I'm not actually going to be using the DEM software. I'm going to show you how to use ParaView to visualize the results and produce fantastic animations that help you understand the processes that are going on in the DEM simulation. I've already pre-run one of the example models, which was the elbow model, which had both spherical cluster particles as well as SPH fluid particles in the model. So to visualize if we look in the G elbow folder, you'll see here that there's all these VTK files. There's out fluid, a bit further down there's out spheres, and further down still there's out surface. So we're going to use those three sets of files for creating the animation. I've already installed ParaView 5.8.1, which at the time of this video is the latest version of ParaView available. So that's what I'm going to open now. ParaView is an amazingly powerful animation viewer of VTK files, but it does take a little bit to learn to use. So with these steps, hopefully I'll be able to get you started a bit more quickly than otherwise. So the first thing we're going to do is we're going to open some of the VTK files. So we'll just go, you can use the file open icon here. I'll navigate to desktop, samples, elbow, and I'll pick up the surface files to start with. You'll notice there that it didn't show all of the individual files, but it just showed the ... to indicate that there's a series of files that are available. So having selected them, I now actually have to hit the apply button. That's something you'll get used to in ParaView, is regularly hitting the apply button after you make some other sort of update. So now we can see the pipe geometry, the elbow pipe, and at the moment it's colored red, which is the magnitude of the surface normals. We can change what the surface is colored by with the color by button up here, and I'm going to set that to solid color, and the solid color currently is set to white, which means that when it's shaded you get white and all sorts of shades of grey. But as you can see also the background is grey, which is the default background that ParaView comes with, so that's a bit hard to see. So the first step is I'm going to change the background. Edit, settings, color palette, background. You can select, for example, a white background and hit apply, and we get a white background, or you can even create a gradient background like that, and that looks quite nice. Now one of the next things you'll notice too is that with this surface geometry is we can't see inside it. Well, we can look down the end of the pipe, but that's not very useful. A couple of ways to be able to see through it once we want to look at the spheres and the particles that are going through it, the fluid particles. One option is to change the opacity here on the left hand side. So you can see here in this window up the top here is the pipeline browser, then underneath it we've got properties and information. Under the properties we can change the opacity here, and we can make it see-through by setting the opacity to point through, or another option, I'll set that back to 1, the opacity back to 1, and we can cut the object with a clip. So up here we've got a few icons here for commonly used filters. This clip one here is what I want, so I'll select clip, and for the clip it needs to know an origin and a surface normal to clip. So I'm actually going to clip it with a Y normal, and I'll leave the origin set to 0 so it clips it halfway through. So I'll apply that, and there we've clipped it. You can flip which side of the clip you keep, either by changing the sign on that normal or by unselecting the invert option down there. By default it comes with the invert checked, I'm not sure why. But that's okay, this is giving us what we want to see. And it's still showing the plane, which can be a bit problematic sometimes because if you click and drag you end up moving the plane around rather than rotating the view. So what I'm going to do is turn that off there. Now we can orient, now we're seeing inside it, and I'll change the colouring back to solid colour. We can see inside the pipe, which is useful. And if we want to be able to see straight onto it, we can use the plus Y. In fact, I'll use minus Y view like that. Move that around, zoom in a bit. So that's looking good. Currently the view, by default when it first starts up, is a perspective matrix view. To get a flat orthogonal projection view, if you scroll down on this properties down here, there's an option down the bottom here called camera parallel projection. Caramel chews would be nice right now. So we'll select camera parallel projection, and now it's just a flat parallel projection. Up the top here, we've got the animation view bar, and it says we've got a maximum of 750 frames. So we can step through the frames using these buttons here. You can either play, which flows through them, or you can just go one frame at a time. At the moment, we're not seeing any differences because it's just set to color by solid color at the moment. So they all look the same. I'll take that back to the start. Now, let's bring in the particles that we want to see. So we'll go File, Open, and I'll select the spheres, and I'll hit Apply. And the first thing you'll notice is that we can't see anything. We just see the pipe. The spheres are only point data. PowerView has no idea what you want to do with those points. So what we have to do is we have to create a graphical representation of the point, which is a glyph. And the glyph filter is right here, this little one here. So I'll select glyph, and then for the glyph type, we've got a few types. We've got arrow, cone, box, cylinder, line, sphere, or 2D glyph. I'm going to choose sphere. There are a few options under sphere. As is common with PowerView, sometimes you get a little button with a cog on it, which is toggle the advanced properties. If I click on that, we get a few more options like the radius of the sphere, resolution options for how finely it displays the sphere and so on. But we'll just accept those defaults for now and close that up. Now further down, we have what we want to do is we want to make sure that PowerView draws the spheres according to their actual size. So the sphere data does actually have information like, well, S max is maximum stress, diameter, the generation number of the particle for breakage models, an ID, number of contacts, velocity, and omega. We're going to select as our scale array the diameter of the sphere and enter in a scale factor of 1. So what that means is whatever diameter is recorded for the sphere in the file, it will use that diameter to rescale the glyph. The next one is whether or not you want to draw every single sphere that's in the file. Generally we do, otherwise the results don't usually make a lot of sense. So I'm going to change that to all points. And that's ready to go, so we'll hit Apply. Now you can see a little sphere has popped up down here. If I move that and zoom in on that, there we go, there goes our tri-particle sphere. If I start to spin that, it kind of moves all over the place when I'm zoomed in. You can actually reselect a new point of rotation using the select center up there, and then I click on that, and now when I spin it'll rotate about the sphere. So you can see there goes the 3 spheres there, and at the moment they're coloured according to ID. I'm just going to set that back to solid colour, and I'm going to redefine the solid colour. Over here we've got a couple of options here, which is for editing the colour map. When you got it set to solid colour, you don't actually get a colour bar option. I'll change that, I'll make the spheres bright yellow. You'll notice in the pipeline browser that we've still got the eye symbol on the out spheres. So it's still thinking that it's drawing them even though it's not drawing anything. And you can see we've got a colour bar down here for the ID. If we just uncheck that, then it doesn't draw them anymore and we don't get a colour bar anymore there. So that's looking good. I'll just go back to the -Y view, zoom in a bit. Now when we play through the animation, you can see all the spheres getting created and moving along. If you want to colour them by velocity, you can just do that there. and now they're coloured by velocity. Maximum speed was 7 meters per second. And you can change the colour scale that's used here with this colour bar button here. In fact, that one just turns it on and off. The next one here is what brings up the colour map editor, and you can change the colour scale that's used. So we've changed it to jet scale, and we can also rescale it here, rescale to custom range. For example, we can rescale it from 0 to 3, for example. In fact, many of them are moving faster than 3. I'll just close that down, and I'll go back to solid colour, so we're back to yellow particles. Now the next thing we want to bring in is the vertex data for the fluid. So we'll go open, out fluid, and again we don't see anything because there's just a whole lot of point data. So again, we have to create glyphs for the fluid, but rather than creating spheres, I'm going to use a more simple glyph, which is I'm going to select a 2D glyph. I have to get the advanced properties there. 2D glyph, glyph type, and I'll change that to vertex. And that's ready to go, except that we need to plot all points, apply, and there we go. Now it's coloured them according to ID at the moment. Again, we can just choose solid colour, and I'll set a solid colour of blue for water. And I can also turn the I symbol off on the original fluid data, so we don't get that legend showing up with ID. Now we'll go back to the start again and carry on. One problem you might notice is the very first time frame doesn't have any fluid particles in it. So if you've got a simulation with fluid and you're trying to create the glyphs on the fluid, make sure that you're not on the first time frame. Make sure that you're sufficiently far along that you know you've got fluid particles to glyph. And that's almost ready to go for making an animation. Zoom in a little bit more like that. Other common things that you might want in an animation is you might want some time information showing on it. So we do that with Filter, Temporal, Annotate Time Filter. And I'm going to use a format width of 6 with 2 decimal places, and I'll put the word S after it for seconds. Now we've got a shift, so time, we'll leave that at 0, so time 0 starts at 0, and scale, this data was output every 0.02 seconds. So we hit that, apply, so there goes a time up there, 0.84 seconds, and then that shows as we go along. I'll move that down to the bottom left corner actually. No, can't see it about the white. Well, that's a good point actually. Something else we might want to do, edit, settings, color palette, we can change the text to black. There we go. Right, now to make an animation, we go, actually before we make the animation, I'll just show you something else that's cool. We can go File, Save State, and I'll select that folder that we were in, give it a name, View. Now that saves it as a state file, .pvsm. We can reload those at a later point if you've got a particular view that you liked and you want to go back to. Okay, to make the animation, we can go File, Save Animation. Now there's a couple of things we can select here. We can either save it as an AVI file directly, or there's other options there, an OGV file, or we can save it as a series of images. I've had a little bit of trouble with saving it as an AVI file in that the options for compressing it don't seem to be working, and it ends up making very large files. So I'm actually going to save it just as a series of images. So I'm just going to do this, give it the name image. We're already in the working directory of elbow, G_elbow, so I'll do that. The other thing we need to tell it is the image resolution. So standard HD movie format is 1920 wide by 1080 high. And that's the prefix or suffix it's going to use for the numbering, file numbering. We'll hit OK. And there it goes now, so it's saving that animation. While it's saving that, I'm going to show you the tool that I use to convert a series of PNG images into an animation is one called Ffmpeg. You can download that off the internet and install it somewhere on your computer where it can find it. It's just a DOS prompt tool. So I'm going to open Command Prompt. I'm going to go to CD. I've got to go to desktop first. Desktop. Epic Examples v1.5 g_elbow. Now if I look in here, that's not very useful. Scroll up here, you can see all of the image PNG files that are getting created. Right, the tool is Ffmpeg. You have to make sure that you've installed it on your path somewhere or modified your path so it can find it. We have to tell it how fast to encode the movie, how many frames per second. I normally use 20 frames per second, so -R20 is the rate of 20 frames per second. We have to tell it what image files to use, so a -I for input, image, tab complete, so you've got .0000.png. We have to change that into a format it can read, 04D PNG. I think it might be that way around, %04D.png. We have to tell it what bitrate to encode at, B for bitrate, V for video, and 10 megabits per second gives you pretty good resolution animations. And then finally a file name. So I'll just give it a name out.avi. Now I'm not going to wait for this ParaView to finish creating the animation. I'll stop it there. That's done. So down here I've got all the image files ready to go. So I hit that. Done. If I now go to the elbow directory, sort by type, you'll see up here that I've got an out.avi file, 27 megabytes, which isn't too bad. And if I double click that and run that, there's our animation. Okay, well, I hope that's been of use to you. And good luck with creating your own animations. And if you have any dramas, please feel free to get in contact with me on support@ffmphysics.com.au, and I'll see if I can help. Cheers. Bye.